Hi guys, are you ready to do some math? Yay math!
Yes!
Yes, yes math! Do nerds walk like this? I am the math nerd. I want to do isosceles triangles because they're so fun. And I walk in place. What am I doing? Walk in place. These glasses actually are somewhat prescriptionized, except they're too small on me. Okay, no, I can take them off. Thank you. All right, so isosceles triangles. It's one of those topics that if you get it, it's fun for life, and if you don't, whoa, still recovering. If you don't get it, then it's, you know, like it'll give you some trouble. So let's give it some trouble. All right, so before we do some of these, I'm going to ask you to draw this triangle. Right? I'll draw it a little bigger. And if I were to ask you, so do we know anything about these angles yet?
No.
No, we don't know anything yet. But what if I said that this side is the same as this side? What would this triangle be?
Isosceles.
Isosceles. Okay, who could raise their hand and say the definition of an isosceles triangle? Anyone else? Okay, please.
A triangle with at least two sides that are congruent, or at least two angles that are
Right, at least two sides and at least two angles congruent. That's an isosceles triangle. All right, so these two sides are the same. There's something else that's the same about them. What would it be? Yes?
On the opposite angles.
The opposite angles. So what do you mean by opposite angles? You're right. The opposite of what? The sides, yeah. So if these two sides are the same, for example, what is the angle that's opposite this side?
The bottom right.
Bottom, this one here, right?
Oh, yeah.
Bottom left here. So that means this angle is the same as the opposite of this side, which is bottom
Right.
right. You guys with us? I know it's Monday. Just, the other day you saw me doing breathing exercises. You can do it right now. Oh, you know, let's get out, shake off the cobwebs. Okay, so that's what it means. If two sides are the same, then their opposite angles are the same. That's the whole point. All right? Let's give you another triangle like this. Please mark the two equal angles. Bless you. Blessed. Past tense. Which two angles are the same? Please mark that on your paper. Take a few seconds. And now volunteer who knows which two angles are the same. You know it? Feeling it? Yeah, what is it?
The top angle and the bottom right.
Top and bottom right, that's right. So these go here and here. Good job. These two sides are the same, opposite angles. So opposite of this side would be this angle, right? It's kind of casting its light onto this wall. Opposite side of this angle is this thing. Opposite side of this angle is this wall here. It's opposite there. Okay, any questions so far? Okay, let's do some of these then. So I'm going to take these down. Bless you. That was good. Back and forth. So, do we know anything about these angles yet? Anything of value for these angles?
No.
No. All right. Maybe do we know something about all three angles?
They equal 180.
They add up to 180. Good, good, good. They all add up to 180. But we don't have enough to solve this because we're missing this guy, right? So what if I said it's now an isosceles triangle? Now if it's an isosceles triangle, look at it closely. And now we can label something. Yes, please.
And the top one is also 40. I mean, the top one is also 2x.
The top one's also 2x. Good job. That was a good correction. How did you know?
Because the three sides are the same.
It's fun to see glasses on you. It's like, did I look like that? It's fun. Yeah, because if these two sides are the same, then the opposite angles are the same. This is also 2x. Sometimes students hesitate of like drawing in their own pictures. Please don't hesitate to do that. If you see something that you know, mark it. So now that we know that these are both 2x, because it's an isosceles triangle, we can make an equation. The equation is, please, yes, see your hand.
180 equals 40 plus 4x.
180 equals 40 plus 4x. That's right, 180 equals 40 plus 2x equals 4x. And then we go minus 40, minus 40. I'm going to bring the 4x over here. Equals 140. X equals, what's 140 divided by 4?
35.
35, right?
Whoa.
4 goes into 120 times, or excuse me,
30.
25 times, and then plus 8. So that would be 35. Plus 10, that's what I meant, plus 10. Okay, so x is 35. And now what are all the angles? 40. This would be 70, because it's 2 times 35. That's 70 degrees and 70 degrees. Okay, and then we can check. 70 plus 70 is 140, plus 40 is 180, so we're good. Now let's do this one. Isosceles triangle, missing angle. What is it? What about left side of the room? This guy, this side, right over here. Should I call on you if you have 2 hands? Okay, 2 hands up, go ahead.
Well, it's going to be 3x.
This will be 3x. How do you know?
Because after the 2 congruent sides and the 2 congruent angles.
Yes, 2 congruent sides, 2 congruent angles. It's the angles that are opposite the sides. Okay, so I know you know how to do this. We'll go through it. 180 equals 90 plus 6x. And then we can solve minus 90 on both sides. 6x equals 90. Divide both sides by 6, x equals 15. Right, and then we can plug it in. If x equals 15, 3 times 15 here, 45. 3 times 15, 45. This is a 45, 45, 90 triangle. All right, I think you're ready for a good one now. This one will rock you. Okay. You have to draw this one fresh. It's not on your paper. So find some place on your notes. We'll be good. There. There. All right, so that's that. Let's plug in some values. 18 degrees, 25, 20. Okay. Alrighty. So far, can we find the angles that are in these 3 triangles here? Yes, hand in the back.
I have a question for the other problem.
These? This one?
Yeah.
Please.
For an isosceles triangle that has a right angle, is it always a 45, 45?
It is. That's right. An isosceles triangle that's a right triangle is always 45, 45, 90 because you assume that the 2 angles must be the same. And if the 2 angles are the same and it's a 90 degrees, they have to be both 45. That's a good point. Okay, let's look at this. I see 3 triangles. We can't really fill in anything until, right? What's going to happen in homework and in tests and stuff is you're going to be given the whole picture, right? You'll be given this already. What I'm doing is I'm trickling out so that you can know what to focus on. So now that these 2 are both the same, we can assume which angles are the same. Okay, I see a lot of wheels spinning in the minds. Yes, please.
The one on top? Like
The one on top is also, what is this one?
20 degrees.
20, that's right. So that's 20 degrees. So if that's 20 and that's 20, we can assume
50? Oh, sorry.
140.
Yeah.
That's right, 140 here. Any questions? No? Okay. So now what if I said these 2 are the same? So try it out for a few seconds.
25 would be at the top.
Okay, no, good question. 25 has to do with this triangle, correct? This triangle is 25. But this triangle is not isosceles, the one over here. So we can't assume anything about what's the same if this triangle is not isosceles. In fact, which triangle is isosceles? This one And
The one.
the middle one? Yeah, the middle one's isosceles. So we have to work with the middle one rule. All right? What do you think? Yeah?
The top two angles
Wait, how do you do them? Are what?
are 81, they're equal.
They're equal, right. I want to first establish this, you guys. This is how I want you guys to think of it. First establish they're the same. Once you establish they're the same, then you can say, okay, all three add up to 180 and on and on. Okay? So, how'd you do it then? Go ahead.
18 plus 2x equals
Cool.
180.
Right, let's do that. 18 plus 2x equals 180. All right, and then subtract 18. 2x equals 162. X equals 81. 81. 81. Okay. And now, let's establish if that's isosceles too. Now, if that's isosceles as well, you can go ahead and fill those in. I feel like you guys really picked this up. It's easy, huh? Is it easy? Yeah, it's easy. That's probably what it is. Okay, so I'm putting 25 here? No, nice. I wanted to see everyone like, no, you're right, 25 here. So 25 plus 25 is 50, 180 minus 50, 130, good. Okay, so that's isosceles triangles. Let's do one proof.
Okay, and now we're done. One proof regarding this. Okay, so let's draw our friends, the back-to-backs. Here they are. A, B, C, D with a line. Okay. Proof. Triangle A, B, E is congruent to triangle C, B, D. And then you have given over here.
Have. Okay, here we go. Given, or gibbon like we said last time. Like screamed at you. Okay, so instead of doing the gibbon as a monkey screaming, we're going to start with the given. ABC is an isosceles triangle. So what does that mean? What does that mean? Yes, in the back.
Segments A, B, and C, D are congruent.
Okay, so let's mark them. Always mark the picture. AB and these two are the same. So let's write that in. AB congruent to CB. Reason? These isosceles triangles
Have two congruent sides.
have two congruent sides. We could even slide in.
Definition of isosceles triangle.
So the definition of an isosceles triangle is more than the fact that these two are the same. So we're going to just explain. Yeah. So isosceles triangles have at least two congruent sides. Okay, so that's one. Let's keep going with isosceles. Now that we know that these two sides are the same, we can conclude. Yes, please.
You can.
Based on isosceles.
That angle BAD is equal to angle BCA.
Cool. Can I use one letter in this case?
Angle C.
Angle C and angle A. We know that these are the same as well, based on this word. So we can write that in as well. Angle A congruent to angle C. And let's explain this one. Isosceles triangles have at least two congruent angles. Okay, so we have two statements of congruency. All right, I'll get out of the way. That. Okay, now we need one more to prove these triangles congruent. Let's do... What do you think? Do you know? I'm in the way? Am I in the way? In the way? Yes, please try.
Do you do the like the
Oh, this one.
middle?
You want to do reflexive?
Reflect.
Let's do reflexive. Let's see what happens with it. So, 1, 2, 3. What would be the statement? BD?
Side
BD.
angles congruent to BD.
BD congruent to BD. Okay, reflexive property. Okay, now I'm going to hit my elevator. Boop. Boop. Okay, so now I'm on the bottom floor. Do we have enough to say that these triangles are congruent? We have a side, and we have an angle, and we have another side. So I see a few heads nodding yes. See a few heads nodding no. What do you think in the back? What do you think? What do you think? Cornelius? Okay. Neighbor to Cornelius. See, what do you think?
I think that we do have enough information because we could use the angle, side angle.
Angle, side angle means two angles.
Side angle, side.
Side angle, side. Side angle, side means that the angles between the two sides.
Isn't it? Yeah.
Here are the two sides, aren't they?
Yeah.
What is the angle that's between these two sides and these two sides?
Angle
ABC.
No. I'm looking at this.
ABC. ABD.
Look closely. The angle that's between these is this angle.
Yes.
This angle is not between these two sides because this angle is also between them. See that? These both are in between. So what's between these two sides is this angle, and what's between these two sides is this angle. So in fact, what letters would this form? Speaking, you know.
SSA.
SSA, thank you. So like, please say it right. Please say it right. Yeah, this would be SSA, right? So, SSA,
It's not a valid posture.
we can't use this to prove that the triangles are congruent. So we're not done yet. We're not done. But did we use everything in our given?
No.
No, we did not. We didn't. Okay, so go ahead.
We can use the definition of bisecting by knowing that a segment BD
Uh-huh.
bisects angle ABC.
Where is angle ABC?
It's the top angle.
Top angle here. BD bisects it. So what happens
So
to
it
the
cuts
angle?
the angle in half and makes those two angles
Makes
equal.
those two the
It can
same.
be
Let's make them mark it with two lines, right?
Yeah.
So statement.
Segment BD bisects angle
Where do you have that?
ABC. Oh yeah, so then it would just be angle ABD
Good.
is congruent to angle CBD.
CBD.
We just like B or
No, we couldn't say just B here, right?
Because
it's
it's
different.
Because there's different angles. We don't know what we're referring to. All right. So
and definition of bisector is angles.
definition of angle bisector.
Yeah.
Now we can say, what can we say? Can we say that the triangles are the same?
Yes.
Yes, we can. Okay. So let's go ahead and say it. ABD is congruent to triangle CBD by. Let me think. Yes, please.
SAS.
SAS. So you're saying SAS? Okay. Could another one be used?
ASA.
ASA. ASA. That's right. Could another one be used? So we have SAS as in side, angle, side, with the angle between them. We have angle, side, angle angle, side, angle with the side between the two angles. Can anything else be used?
You could get an AAA, but
AAA doesn't work for triangle congruence.
Nothing.
The SSS does.
SSS does. Can we say anything about these sides based on the givens? We can't. We can't say anything of these sides right now, right? So we have to just stick with one of those. So we heard SAS was the first one, we'll use that. We'll even put it, or ASA. Follow-up question? Do you have a question? No? Okay. Okay. Ooh, it's a fire drill. Okay, everyone, say bye.
Bye.
Bye. Let's go, fire drill.